Hello everyone and welcome back to another project entitled as data transmission using light or light fidelity with Morse code encoding. So initially I'll be talking about the features of my project and some of the technical aspects. Then I'll describe the components that I've used here, and finally I will show you the demonstration, the way the project works. So with no delay, I would like to dive into the features of my project. So we will be transmitting data, more specifically text or string, from one end to the other end. Now the transmission medium or the communication medium can be either free space or it can also be the optical fiber. But in our case, I've used the free space optical communication concept. The range in my case might not be that much high, but we can easily increase the range by using a powerful laser module at the transmitter end and by using a solar panel at the receiver end. However, if we use the optical fiber as the communication medium between the transmitter and the receiver, then the range of communication can be extended a lot. So, as I've already told you that I will be transmitting string or text from one end to another end. So the building block of a string is word. The building block of a word is characters, and each character has 8-bit ASCII value. So transmitting a single character means transmitting a byte or 8 bits, and we will be transmitting the bits using the light pulse. That means the presence of a bit, that means bit 1 means there is a light pulse, and no bit, that is 0 bit, means there is no light pulse. Now the concept might be very simple, but the synchronization between the transmitter and the receiver to decode the received text properly, it's really very tricky, I should say. And then after the entire string has been received by the receiver, the received string will then be encoded into Morse, and the Morse code can be heard from the buzzer. Now the input string at the transmitter end can be given as input to the transmitter from the serial monitor, but in my case I will be using my cell phone to send the data or string which is to be transmitted to the transmitter ESP32 board using the serial Wi-Fi terminal. So I will be using my cell phone with the serial Wi-Fi terminal to send the input text which is to be transmitted by the transmitter. After that, the received text by the transmitter ESP32 board will be encoded into binary values. Then the binary values will be sent using the light pulse, and the light pulse will be decoded by the receiver ESP32 board, and we will be able to see the decoded string on the LCD display. And we will be able to hear the Morse code, but it might be a bit difficult to decode the Morse code. So in that case, I will be copying the Morse code from the serial monitor as it would be printed there consistently, and then I'll be translating it with a Morse code translator just to verify if the received string is being encoded with Morse coding properly. So that's all about the features of my project. In the next part, I'm gonna talk about the technical aspects of my project. So right now I'd like to talk about the technical aspects of my project. So as you can see, at the transmitter end we have used an LED, and at the receiver end I have used an LDR or a photoresistor, also known as the light dependent resistor, with a voltage divider network. That means, as you can see, this is a 10 kilo ohm LDR which is connected in series with another 10 kilo ohm resistance, and I will be reading the voltage from the common point. So if the voltage exceeds a pre-calibrated threshold value, then the received light pulse will be considered as a bit. After that, the bits will be transformed into bytes, and from the byte we will be able to recognize the character, and from the character eventually it will be able to decode the entire string. Now the most challenging part here is to establish proper synchronization between the transmitter and the receiver. So to do that, I have used a start bit and a stop bit at the beginning and ending of the data transmission. So for the synchronization purpose, whenever the data transmission is initiated, the transmitter ESP32 board will be triggering a falling edge of the input clock pulse. As a result, at the receiver side, the photoresistor will get to understand that yes, the transmission has begun, and it will start receiving the bits one by one accordingly, and then start to form bytes, and from byte it will be decoding it back to the ASCII character. So the sampling time or the bit duration is very important here. The sampling time at the transmitter end and the sampling time at the receiver end, or the bit duration, they must be the same. Otherwise, there might be ambiguity or the lack of synchronization between the transmitter and the receiver end, and we might not be able to receive the bits properly at the receiver end. After the bits have been received by the receiver, they are then decoded back to the original string, and after that the original string is being encoded using the Morse code, and it is being played with the buzzer, as you can see here. So to ensure that the Morse code is being encoded properly, we'll be copying the encoded Morse code, and then we will be using a Morse code translator just to see if the encoding process was perfect, and we would be able to show the appearance of the characters or the decoding of the characters in the LCD display one by one in real time. As I've already told you that the communication range can be increased by using a powerful laser in case of free space optical communication, or by using an optical fiber in case the range is to be extended a lot. So that's all about the technical aspects of my project. In the next part, I will be describing the components that I've used here. So as the microcontroller, I have used the ESP32 boards. As you can see, the ESP32 board on the right, it's my transmitter ESP32, and the one on the left side, it's my receiver ESP32 board. The reason for using the ESP32 board instead of Arduino is because of the fact that it's very compact, cheaper than Arduino, as well faster than Arduino. I mean, it has a higher clock frequency. At the transmitter, I have used I have used an LED that will be transmitting the light pulses, and at the receiver end, I have used the LDR. I have used a 10K LDR, or the light dependent resistor, also known as the photoresistor, with a voltage divider network. That means it is connected in series with another 10 kilo ohm resistance, and the voltage is taken from the common points. In order to play the Morse code, I have used the buzzer module, as you can see here, and I have used a 20x4 LCD display, including the I2C driver, that eventually allows me to work with the least possible number of wires, as you can see here. Now, as the power supply unit, I have used this pair of lithium-ion batteries, which will be generating around 8 volts when they are completely charged. However, the LCD display is not 8 volt tolerant, rather it is 5 volt tolerant. So I have to step down the 8 volt generated 8 volt by the pair of lithium-ion batteries to 5 volts. So to serve that purpose, I have used the LM7805 linear voltage regulator, and the output of the LM7805 is 5 volt, and I'll be using that to power my LCD display. So that's all about the components that I've used here. In the next part, I would like to show you the demonstration, the way the project works. So right now, I'd like to show you the demonstration, the way the project works. So as you can see, I have both of my ESP32 boards powered on, and I would like to show you the real-time demonstration right now. So I'm resetting the ESP32 board on the receiver side just to show you everything from the beginning. As you can see, I've reset and LiFi decoded received message. So as you can see that I have the Wi-Fi serial terminal over here, using which I'll be sending the text which is to be transmitted to the transmitter ESP32 board. And you can also see it on my screen. Let me clear the serial monitor, clear output. At the communication 5, I mean COM port 5, we have the receiver ESP32 board, and at the COM port 7 we have the transmitter ESP32 board. So right now I would like to send a text to the transmitter that would eventually be transmitted. So the input string that I would like to send initially is hello, I'm Rafi, and we will see what happens in that case. So yes, I have transmitted the data, and as you can see in the display that the received data, the received string is available. The blue LED on the transmitter ESP32 board over here indicates that the data reception was in progress. As the data reception is over, the blue LED on the receiver ESP32 board will get turned off. And on the serial monitor, COM5 receiver serial monitor, as you can see that we have the received text as well the Morse code, and we can also see the received text in the LCD display. Now this character and at the end, it indicates that the transmission has been ended. It indicates the end of transmission. So I believe that you are able to see the light pulses being transmitted when I sent the string to the transmitter board. Now let's send another string. Say the string is the Optical project is working perfectly, and let's add some digits over here, 1 2 3 4, and I'll be sending this string right now. So as the LCD display is filled with the text, then the display will be cleared and the subsequent characters would be printed accordingly. For the sake of clarification, I will be also translating the received Morse code just to show you if the encoding process was working perfectly. So in the serial monitor, from the serial monitor, I will be copying the Morse code, Control C, and then I'll be going to a dedicated website over here that can translate the Morse code. So as you can see, hello, I am Rafi. So the encoding with the Morse code was perfect. So in the next part, I'm going to send another string, as you can see. So I will be clicking on the send button and see what happens at the transmitter and the receiver, and also on the LCD display. So you can see that the data is being transmitted. The blue LED is on, the red LED on the transmitter side is blinking, and we can also see the received text on the LCD display. We can also hear the Morse code, and on the serial monitor you can see the Morse code is being printed. And if you want to, we can also verify if the encoding of the Morse code was correct, because it's not that much convenient to decode the Morse code as you are hearing from the buzzer module. So in that case, you can copy the Morse code from the serial monitor and then use a Morse code translator on the website that I've already shown you to check if the encoding was perfect. So that's how the encoding process is working. I'm showing you for one last time. I will be transmitting the message. As the message would be transmitted, you will see the flashing of this LED on the transmitter side. And when the receiver will be turned on, I mean, as long as it will be receiving the characters, the blue LED on the receiver will remain turned on. We will be able to see the received string on the LCD display. And I would like to, and then the text would be encoded with the Morse code. And as I've already shown you that the encoded Morse code can be verified from a Morse code translator from any website. So right now I'm sending the string once again to show you the demonstration if it is working properly for one last time. So as you can see that the LED is blinking, the Optical project is working perfectly. 1 2 3 4. So 1 2 3 4 was printed, just to let you know that the numbers are also being encoded properly. If you want to, you can copy the Morse code. So let's do it from here. Okay, first of all, the encoding has to be ended. So let's wait until the encoding is over. And after that, we will be verifying if the encoding process was correct using a Morse translator. So let's wait a bit until the encoding process is over. It takes a while. As you can see, yes, the encoding process is over. I will be copying the Morse code right now from here. It's a long code, Control C. I've pressed on Control C, and now as you can see, we can verify it. Yes, the Optical project is working perfectly. 1 2 3 4. So that's how the project works. As I've already told you, you can increase the length by using a laser module at the transmitter end and a solar panel at the receiver end. And to increase the range of communication to a great extent, you can use an optical fiber between the transmitting LED and the receiver photoresistor. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.